This is a video for Geometry Chapter 2, Lesson 1. Okay, so we're beginning our logic, all right? The beginning of the textbook, you read about inductive versus deductive logic. We're going to use deductive logic, whereas inductive logic goes from fact to prediction, sort of like our weather, right? They're predicting where the hurricane will land and how strong it will be. Deductive goes from fact to fact. A deductive thought would be if a number ends in 0 or 5, it is divisible by 5. Okay, so we go from fact to fact. It is critical thinking. We use definitions, properties, what we're going to call postulates to arrive at conclusions, okay? So, looking at page 42, we will use deductive reasoning. It is critical to fundamental to critical thinking, all right? Now, look at, it says toward the end of the mystery of murder on the Orient Express. Poirot, that's how you say it, Poirot reasons. Look at the if statement. If Ratchet had been heavily drugged, he could not have cried out. That is a conditional statement. If Ratchet had been heavily drugged, the if part is the condition. Okay? The if part is the hypothesis. It's the condition. If this happens, so if Ratchet had been heavily drugged, that's the hypothesis, then what is the conclusion? He could have cried out. He could not have cried out. That is the conclusion. That whole statement is called a conditional statement. It has a hypothesis, which is the if portion that results in a conclusion, which is the then part. Your textbook says, if A, then B. This whole statement is a conditional statement. Okay? The if part being your hypothesis, the conclusion being your then. Okay? So the Bible has these. In John, the book of John, chapter 15, verse 6. Listen to this. It says, if anyone does not remain in me, that's the hypothesis. If anyone does not remain in me, here's the then part, the conclusion. He is thrown aside like a branch and he withers. The next verse, verse 7 of John 15, also has a conditional statement. It says, if you remain in me and my words remain in you. So that's the condition. That's the hypothesis. And here's the conclusion. Ask whatever you want and it will be done for you. Okay? So we see these throughout Scripture and we use conditional statements in our arguments, in our proofs. We can not merely just write the statement, we can also represent it in a diagram that is very similar to diagrams that we use in English, like a Venn diagram, all right? But this is called a Euler diagram. E-U-L-E-R. All right, so some teachers call him Euler, but I find that the majority of your college level teachers refer to him as Euler, but you will hear Euler sometimes, all right? So utilizing the same A to B as we write it as a statement, we can represent it as a diagram. Our condition, our hypothesis is the smallest circle, and our conclusion is the biggest circle. So going back to what Poirot reasoned, the A part would be if Ratchet had been heavily drugged. So A would have been Ratchet heavily drugged. The B part would have been he couldn't have cried out. Look on the top of page 43. There is a conditional statement. It begins with, if the crime was committed at 1:15, that's your hypothesis. The murderer couldn't have left the train. That's your conclusion. As a Euler diagram, on the innermost circle, it would have been crime committed at 1:15. The conclusion on the outer one would have been murder couldn't have left the train. What if I wrote this statement? If you are 16 years old, then you may obtain a driver's license. My hypothesis is this first part. This part here is my hypothesis. This part is my conclusion. The whole statement is called a conditional statement. So the entire statement is called a conditional statement. If I were to represent this in a Euler diagram, it would be 16 years old would be my A part. May obtain driver's license. That would be the Euler diagram. Look at the Euler diagram on the top of page 43. If we're looking at a Euler diagram and we want to go to the conditional statement, look at what's in the smallest circle. The hands of the watch were altered. Look in the bigger circle. The time must be important. So if I were going from the Euler diagram to the conditional statement, this is how I would read this. If the hands of the watch were altered, then the time must be important. Right? That's how you would write that. Let's do another example where we're given the Euler diagram and we go to the conditional statement. That's keep my commandments. So given this Euler diagram, I could write a conditional statement. The hypothesis is keep my commandments. The conclusion is abide in my love. So what would the conditional statement be? If you keep my commandments, then you will abide in my love. Okay? So this lesson is all about conditional statements. Now, we must ask ourselves, are they necessarily true? All right, so let's go back to the statement about driver's license, and I'm going to change it a little bit. So, I'm abbreviating a little bit. Okay, let's look at these two statements and let's ask ourselves, are they necessarily true? Here, the hypothesis is you're 16 years old. The conclusion is you have a driver's license. Notice what I did. I took the conclusion here and wrote it as a hypothesis. I swapped the hypothesis and conclusion. If you have a driver's license, then you are at least 16 years old. Okay, is it true to say if you're 16 years old, then you have a driver's license? So you ask yourself, does every 16-year-old have a driver's license? That is not true, right? That's not true. There are some 16-year-olds that don't have a driver's license. There are probably some 70-year-olds that don't have a driver's license. Now look at the second statement. If you have a driver's license, then you're at least 16 years old. Is that true? Yes, because in our state, to have a driver's license, you must be 16 years old. So we also have to ask ourselves the truth value of these conditional statements. That is lesson 1.